Yep, it's live now. We're live.
Yeah. Did it say that on yours too?
Yep, it does.
Sidetracked. I was doing homework. Now I'm looking at
A lot of people there, huh?
Yeah, a little bit. It'll be good.
You ready?
Yeah, I'm ready.
Okay. Go for it.
Alright, so in number 6, the mean score of all GRE scores is 150.8 with a standard deviation of 8.8. And so A, scores on the quantitative proportion of the GRE are approximately normally distributed with MU equaling, I'm going to say 150.8 and the standard deviation of 8.8. Am I correct?
I know.
I don't know.
Oh, okay.
Sorry.
Alright, not to worry about it.
They're normally distributed with the mean. What's that? Is the the symbol with the upside down H looking M thing? That means mean, right?
Yeah, the mean of the population. It looks like a U and an M. Well, at least from the tutorial, from what the guy said. That's why I just took the thing to mean. But yeah.
I thought that number meant mean. Am I wrong?
No, you're right. It's the mean of the population.
Mean of the population. So specifically, mean of the population.
Yeah.
And that little the other symbol next to standard deviation. Does that mean standard deviation?
Yeah, the O with a little thing on it means standard deviation of population.
Okay.
Yeah, so when I see the standard deviation, I think of it as 8.8 because there's not how many of them are there. It's the standard deviation of the population just in general. Yeah.
Mean of all G's. Quantitative portion distributed with the mean. So where did you get that?
The GRE scores of 150.8?
Yeah, 5A.
Yeah, so I got that, like, I was actually just kind of guessing at it, but at the same time, the mean of the population, that's why I thought the 150.8 was the mean of the population, because that's what all the GRE scores is 150.8.
Yeah. Okay,
Yeah.
so of all GRE scores is 150.8. But then, so the quantitative portion, where did you get the information for that?
So what proportion of the people who take the quantitative portion of the GRE will score above 165? Is that what you're asking?
Yeah.
All right, so 165, I'm going to do my little calculator thing right now. So if we do 165 minus 150.8 divided by 8.8, we get a standard deviation of 1.613, or 1.614.
Sorry, hold on. Can you grab me? Do you need me to go somewhere else?
Yeah.
Where am I? Whose room am I supposed to use?
Can you use the girls' room?
Sure. Hey. Sorry.
Hey, don't worry about it. While you're moving, though, I can load up that little chart thing.
What chart thing?
Yeah, so they have this it's a belt thing.
Yeah, the bell curve.
Yeah, they have that, and I do not have that pulled up, sadly. So I'm going to pull that up while you're moving around.
Okay.
So that way I give you time.
Okay, yeah, you can go to the girls' room.
Okay, thanks.
Yeah, just tell Sarah.
Okay. out of my room and do my homework.
Yeah.
Okay.
Probability outlet. Come on, load up.
Am I sitting in your bed?
What's up?
Am I sitting in your bed?
Yeah, no problem.
So did you get the information for the quantitative portion of the GRE? Was that in the workbook?
No, I just put 165 into the equation, and then it came up with a 1.614. So I was actually just doing some math there. That's all.
But okay. Well, 150.8. So the okay. You know what? I started watching the video. I watched the first one, and I fell asleep.
Oh, really?
Yeah. So I don't know what's going on with this lesson, and I'm gonna have to do it tomorrow and just catch up.
Okay.
I spent the whole day interviewing and applying for jobs, and
How'd it go, by the way?
pretty well. One of them went really well. I think So I went to turn in a resume and just meet them, and they wanted to interview me, and I think I'm gonna be. They said that they'd call me next week and ask me when I could start and stuff. So I think that went really well.
Oh, that's good.
Yeah. I'll be working with the disabled.
What was that?
I said I'll be working with disabled people.
Oh, sweet. Are you like helping them get jobs and everything?
Yeah, that'll be part of it. Helping them get jobs, helping them with skills training and helping them manage their appointments and so on.
Sweet.
Yeah. Yeah. It took a lot longer than I thought it would. I just got back like maybe half an hour ago.
Okay.
Huh?
Okay, so while you were talking, I was able to get this normal probability applet up.
Okay.
And what I did, so I put in the equation of 165 minus 150.8 above 8.8, and then I got 1.614 rounded up, of course. And then I just put that into the z-score of the normal probability outlet, and then the area came up with 0.0533. That would be, if a student's score is in the 10th percentile, what would their corresponding z-score be?
But don't you need the mean of the quantitative portion?
The mean of the quantitative
Or don't you need the data for the scores on the quantitative portion?
I think so. I'm just applying to the knowledge to the best of my ability.
But don't. So they give you the 150.8.
Yeah, they give you that.
But they don't give you any data for the quantitative portion.
Well, the quantitative portion will score above 165. Wait, what proportion? Oh, what proportion of the people who take the quantitative proportion?
I'm talking about Part A.
Part A. Okay. So I just put that at 150.8, which is okay. I wonder, can you see this?
Yeah.
So 150. I hope this is okay. So 150.8 I put as part 2 of the top fraction, if that makes sense.
Yeah, I got that.
Okay. So what are you asking? Sorry.
So you have 150.8, right?
Yeah.
And that's the mean, and then they give you the standard deviation 8.8.
Right.
but they don't give you any information on the quantitative on scores of the quantitative portion.
Nope, they don't. So that's why I just imported the 165 because I just saw a number and I imported it.
So you just took the 165 from Part B?
Yeah, I just took the 165 from Part B because that's what.
Well, who take the quantitative portion will score above 165, but that's not. I feel like I'm missing information. I feel like we need information on the scores. All scores, I guess all scores include quantitative. Okay, so quantitative. So wouldn't it be 150.8 and then scores in the are approximately normally distributed? Wouldn't it? So okay. What did you say for A again?
For A, for the first part, I put 150.8.
Yeah.
And then I put 8.8 for the second part.
You wrote that for A?
Well, 150.8 and then 8.8.
Yeah,
Wait a second. We have an answer sheet, dude. I totally forgot about that.
Yeah. I just thought that too.
Well, yeah, let's take a look at this. Okay. So go down to part B, part 2. Yeah, so the mean is 150.8, and then standard deviation is 8.8.
That was so. Why did I can't believe I made that as complicated as I did. I just figured that that was a different part of the test, and we needed some. Okay.
Well, I do admit I did.
I thought that they were giving us the 150.8 and 8.8 as these are the general tests, but that the quantitative portion of the test had a different made up part. I'm not sure that I'm explaining myself very well.
I think you're tired.
What?
I think you're tired.
No. I'm thinking.
Oh, okay.
What I mean is so if you have, let's say the GRE has 3 different portions, right? I think it does, doesn't it?
Yeah.
Well, so it's language and writing and quantitative, isn't that it?
Yeah, I think we're on the same page.
Something like that. So the language portion, if the mean language for the scores in the language portion could be 145, while the mean for the scores of the quantitative portion could be 150, because maybe overall, on average, students do better on the quantitative portion than they do on the language portion, and then finally, the writing one could be higher. It could be 160, and so or 162, let's say. So the mean for that one would be 162, and then for the other one would be 140, and the other one would be 150. But if you took all of those scores and then you took the mean of the total scores, then it would be around 150.8. And so I thought we needed information about how, I thought they were giving us general information on how the scores are as a total, but that we were missing information about the scores of specifically the quantitative portion. Does that make sense?
Okay.
It doesn't matter. I was wrong. Okay. Now that we're on the same page.
All right. So now that we know we have the answer key, we can definitely check the answers to make sure that we are along the same page, of course.
Yeah.
All right. So But I was wrong when I checked over my answer sheet because since I rounded up, I actually did get the wrong answer. So the area would have been like 0.534, 0.0534. Wait a second. What the heck?
The standard deviation of so it's where's my cursor? The standard deviation would be isn't it 65? Isn't that the number? Magic number? 68.
Here's SAB Iowa.
Oh. So the first thing that you need to do would be find the oh, I hate this. I'm not very good at this. Is to plug it into that formula with so how if you add
No.
8.8 to 150.
Tell me about your family.
Oh, okay.
You know what I'm saying?
I'm just looking at the solution of part A of number 6. So, like, I was right on the first part of it, and then so P would parentheses X is greater than 165 equals P is greater than what? Oh, Z-score. Yeah, the Z-score is 1636. And so if we, okay. Ugh. I don't know.
So if the mean is 150.8, the standard deviation is 8.8.
Right.
Then you add, so for this first, to find out what that first, the 68%, or the 68% portion, you add 8.8 to 150.8, right? And you get 159.6. And then if you do it a second time,
Sorry, not means you go to the funeral. They have to change the body?
They usually bury you.
168.4. So the question was,
I think it's people who are temple workers.
okay, so we know that 90.
Thank you. Because I know several people who were
95% of the population
some of them
scores less.
others were. So my grandmother on my
Less than.
temple clothes, since she was a temple worker.
That's not quite right.
However, my father's father was not. He was not a temple worker. My parents are old, so there's a lot of truth on safety. And my principal.
I'm sorry, I just lost focus for a second.
He just died, and he was buried in.
Okay, so we know that
So
we know
that
90.
for allowing people with it. I do know that there was something about that I read recently.
95% of the population falls between 168.4 and 133.2, right?
Yeah.
Where are you getting these numbers from? Just curious.
So you remember the rule, the 68-95-99.7 rule?
Yeah.
I don't know.
So I'm just adding the standard deviation
Answer the person's
to
question.
the mean. And then subtracting the standard deviation. What I did was I added the standard deviation to the mean and subtracted it from the mean, and I came up with 159.
Wait, one more time. 3 what?
Oh, so you did like the whole numbers like 1, 2, 3 as the Z? Is that what you did?
Yeah.
Okay, okay.
The second one is I took the mean and I added 8.8 times 2, and then I subtracted 8.8 times 2. So that's where the 168 and 133.2 comes from.
Okay, got it.
Is that even? I don't know if that's relevant. What proportion for above? So that's.
Come on, baby, come on.
I'm. Is it 25%, or is it? I mean, is it 33%?
Sure.
Are you not sure?
I'm not sure.
Well, let's check.
All right.
I'm off this good grapes.
All right. So what problem? So first off, what problem are you on?
We were looking at the question. What proportion of the people who take the quantitative portion of the GRE will score above 165?
Okay.
And what did you get?
Well, with the information I had 0.053, but now that I'm looking, I'm like, that can't be it. Wait. No, wait, it is it. Okay, so I'm looking at a solution, and I'm looking at the normal probability applet, and I'm just highlighting the like 95th percentile or whatever that is.
Yeah.
And it came up with a 0.0534, and like that's the closest thing that came to the solution.
Yeah. 0.053.
Yeah.
Okay.
So so that's the closest that it came to the solution.
Okay.
Yeah. All right. So the students score. So we're going to point to B now.
Mm-hmm.
If a student score is in the 10th percentile, what would their corresponding Z-score be? So I'm going to highlight the other section because that's what it's saying to do. And it's a C. Okay, so it's 1, 2. Oh, wait. Z equals. So it has a solution as Z equals 1, 2, 8, 1, 6. That goes to question 1. But where did they get the 1.0? Where did they get that number? And where did they get the negative 1.2816? That's question
1.
Okay. Yeah, where are they getting that number?
Ooh, look at you, bro.
Here.
They don't really give an explanation for that one, do they?
No, they really don't.
What did you get?
Oh, for the B?
Uh,
For B?
yeah.
I haven't really figured out how they did it. So let's see. Okay, I'm just gonna do what they did on their charts. Okay, so they just had 0.1 as the area, in the area. Let's see where they... Yeah, that's weird. They don't really give it to you.
No, they give you the answer, but they don't tell you how they got there.
Hey, do you have the information pulled up for the 2.2.2 baseball averages?
No, do you want me to?
Sure. That way we can like split up the work a little bit. So that'll be in your folder of the preparation homework. It should be like the top one, and then they have it in little sectionals.
The normal distribution
Yeah.
part from the textbook.
I just said I wanted to.
Because I wonder if they have the answer within that little section area. You know what I mean? Like how they even got that number.
I work here too.
You know what? I don't think I can afford it. It's not my budget.
You don't have a budget.
No, but I should start because based on what you told me.
Start
I can help you with that.
Wait a second. 10th percentile, 0.10. Ugh. Now it makes sense of why it is that number. So like 0.10 is like 10 in decimal form.
Yeah.
Or percentage form. I didn't get that until now.
Yeah. Yeah.
Great.
Okay. Do you understand now?
Yeah, I do. Now I understand how they got that number.
Okay. Do you want to explain it to me?
Okay. So what happens is when you get a 10th percentile, you put the 0.10 in the normal probability applet area section, and then it just comes up with z-scores of 1 for the negative 1.282, and a z-score on the other side is positive 1.282.
Okay.
And so that's how they got that for the solution for part B. And who score above the 165 is, yeah. So it's not unusual.
Okay, where's that?
Okay.
Oh, no, that might be.
Shall we move on to the next one?
Sure.
All right. If a student's score is the 10th percentile, what would their corresponding z-score be? That would be, well, from what we gained, it would be negative 1.282. But the solution says the z-score is negative 1.2816. It's just rounded up. So solving the following equation for x. Huh. Okay. So let's see if I can do this. So the z-score is... Okay. So x equals 150.8. Then plus a negative 1.2816 times 8.8 equals 139.5, which rounds to 140. Okay, so how'd they get that though? So what they did was they added 158 to both sides, and so eliminating each factor. So let's say we're just going to do 1. There's 1.6. 136? No. Oh, it's not. Sorry. It is 1.2816 plus 150.8 times 8.8 equals. Okay, I totally think I got that wrong.
The z-score of the 10th percentile is 1.816. Solving this following equation for x. X is
Well, they didn't have any blue and black. I just,
you have the equation right.
again,
I do?
Yeah, you had it exactly right. Is 150.8 plus the z-score times 8.8 or yeah 8.8.
So I think so. It might be just my calculator then.
Plus, yeah, plus the so it was 150.8 plus negative 1.2816 times 8.8, and the number is 139.5.
So what was the x then? X was
X
Oh,
is
158.
the mean plus the z-score times the standard deviation.
so the answer that they just came up with was 140.
Uh-huh.
Oh, okay. So we were solving for that. Okay, got it.
Yeah.
Yeah, so I think it's just my calculator. Like this is all I have for a calculator on my phone.
Oh, use Excel. It's better.
Yeah.
Or get a graphing calculator.
Yeah, I can do that when I travel down to Utah, my next visit, which is this weekend.
Yeah.
So, like, it helped out a little bit. It got me around the same number. It just had an extra number in there.
Yeah. Yeah, and they warned us that Excel and I can't remember SPSS. They use slightly different. I don't know, and so that are when we use them as calculators, we might get slightly different numbers. So, I don't know. Next one.
Yes. All right. So, what is the quantitative GRE score for a student that? Did we just solve that one? No. Sorry.
We're on
D. But it doesn't have it. But it doesn't have a D.
It does. It's so there. So if you look at the answer sheet, they included so if you look at the non-answer sheet, A is just part of, or A is its own thing. But if you look at the answer sheet, A is part of the beginning statement, and then they give A is B, B is C, and C is D. It's kind of confusing,
Oh.
but it's all there.
Okay.
So we're on D if you're looking at the homework, and C if you're looking at the answer sheet.
Okay. So C. What is the quantitative GRE score for the student who scores in the 10th percentile? 1.2. So negative 1.2816. Is that correct?
I think so.
All right.
Okay, what about?
I think so too. Number 7. The mean of hydrogen at room temperature is 1800 ms with a standard deviation of 600 ms. So I'm just going to write this out really fast. 1800, 600. Okay. Equals Okay, at room temperature, the mean speed of hydrogen H2 particles is approximately normal with a population mean of the squiggly thing meters per second and a standard deviation of O circle thing.
What?
It's A.
Okay. The squiggly thing and the O circle thing.
Yeah, the O circle thing.
I got you.
Watch my pen. Watch my pen.
I've got so is that the squiggly thing that you said, does that just mean mean?
Yeah,
That's the symbol for mean?
the mean of the population. The standard deviation with the O acrylic thing, whatever it is 600.
No, I'm not asking that. That O with the little stick on it,
Yeah,
that's the symbol for standard deviation.
of population. Yes.
What's of population?
I would just say that. Well.
Oh, so the standard deviation specifically for this sample,
Yes.
and the mean specifically for this sample.
Yeah.
Okay, I follow now. Thank you.
Yes.
I-
You're welcome.
You cleared that up. Okay.
Okay.
So yeah,
So-
it's 1800 and 600.
Yep. So that we got that right.
Yeah.
B. What is the probability that a randomly selected particle has a speed of over 2,500 ms? Okay. So put the 2,500 in your little fraction area. Can you see it?
Yours?
Do you see it?
Yeah.
Okay. So 2,500 minus 1,800 over 600. That's what we're doing. And then it's just asking for that. 2,500 minus 18. Nope. Then we have to do that again. 1,800 divided by 600 is 1.16 sixes with a 7 for the roundup. So we put that in the z-score of our little template, 1.667, and then we get, let's see, 0.478. Why is it different? Ugh.
You have it. It's 2,500 minus 1,800, and then you divide the whole thing by 600. Are you just frustrated with your calculator again?
No. It's not the calculator that I'm frustrated with. It's the normal probability applet, because the reason being is my answer is totally different from what they have as the answer.
Okay.
Oh, wait a second. Oh, there's my problem. I didn't incorporate another one. 1.1667. There we go. That looks more correct. So it's...
I got 1.166667.
Yeah, with a roundup of the 7, right?
What?
With a roundup of the 7, right?
Yeah.
Yeah. Okay. So it could have been my calculator again, but oh well. This is not going to help me in this class with this little phone calculator.
You gotta use Excel.
What was that?
Use
Oh.
Excel.
It's hard for me. Well, I just find it difficult to get into the program.
What do you mean?
Like, I don't know where to go most of the time.
To get into the program of Excel?
Yeah, because like when I tried entering it from this computer the first time, it kicked me out of the place where I'm at right now, and I just had to go through all the process all over again, and I had to just like get really into it again.
Do you have a laptop?
Nope, I do not.
Oh, that sucks.
Yeah.
Especially with an online class. That's rough, man.
Yeah, so I just go to the library all the time. I've gotten used to it. I've done it for years.
You said they have a
Math lab?
Yeah. No, not a math lab. You said you have a graphing calculator at home. Can you ask them to send it to you?
Well, since it's like a 3-hour drive for me, I can just like drive down there and it'll be no problem. I was actually contemplating on selling it, but now I would highly regret that decision if I did.
Because you're right, man. Your phone's not going to cut it.
Yeah. They helped me out on a few problems, but a few problems won't get past the class for me. That's for sure.
No. So yeah. So it says P X is greater than 2500 is equal to P in parentheses Z is greater than 1.1667.
Mm-hmm. And the area would be 1.1216, but it has on the answers 0.1217.
Yeah.
So we go to C then. What is the probability that a randomly selected particle has a speed that is less than 2500 ms? So then I select the other areas, and then I think it is 0.8784 or 0.88. Am I right though?
Can you say what did you say?
Oh, I'm just doing the same thing that they were doing.
Yeah. What did you say?
Okay. So what I did.
It was what I'm saying.
You didn't hear me. Okay. So instead of having one area highlighted, I just unhighlighted that area, then highlighted the other two areas, and then I was given the area of that answer, which was 0.8784.
Yeah, they say 0.8, or they say instead of 4, it's 3, but
Yeah.
close enough.
Yeah. So that's C right there.
From 1. Part A from 1. Part B, Part A. 1. That's interesting.
The answer is easier to get by subtracting the answer to part A from part 1.
And by Part A, they mean B.
Great. Perfect.
So 1.1. So P. So where do you? So I get that little equation that they give you. The Z is equal to X minus mean, and then divide the whole thing by the standard deviation.
Yeah.
X. And then they give you this, so you find out that Z is 1.1667. How did you get the area from that?
So in the normal, so there's a little tool in the BYU Idaho thing. It's on that same little. So you go into that instruction page, like the.
Is it in the SPSS thing?
Well, it's not the SPSS thing. It's the introductory homework thing, like the homework you're supposed to do for yourself. Like when you're reading over the material, they have a little main page thing on the side, and then you click on main page, then you go into the tools of the, well, go into the resources, then you go to the normal probability applet, and that's how I got my answers the way I did.
Okay.
They actually show you how to do that in the tutorial.
Okay. And that was in this lesson's homework?
Yeah.
Okay. All right. I'll review it.
Yeah, it's a really helpful find, especially for this homework.
Okay. Okay, next one.
All right, D. What is the probability that a randomly selected particle has a speed that is less than 1,500 ms? Okay, so what you do is you do, okay, so 1,500 minus 1,800. I'm looking at the answer sheet.
Yeah.
Then divide that by 600. So you get 300 on top, and then 600 on bottom, and then you get 0.5. negative 0.5.
Uh-huh.
But how do we get there in the first place? That's the better question.
I like formulas.
Formulas are awesome.
Yeah.
What is the probability of speed that is less than 1500? Like, where do they get the 1500 from? Oh, wait. Hello. The 1500 is the x.
The 1500 is, yeah. Exactly.
Yeah, 1500 is x. That's why I was like, wait, where did they get this number from?
Okay.
One of my blonde moments. Anyways, so E. Am I correct? Wait, no, we're not done with the D, are we?
I thought, yeah. Wait, so you said, so from the equation you get negative 0.5,
Yeah.
and then you plug that in, and it spits out 0.3085.
Yep.
That's what you got too?
Yep, I did.
What is the probability that a randomly selected particle has a speed that is between 1500 and 2500?
3829.
You got 3829?
Well, I just highlighted the second part, well, the section, the center part, and I was wrong.
Yeah.
Uh,
So it's 0.56. 0.5698. Concept of subtracting these may be new to students. Probability of 1500, which is greater than, or x is greater than, less than 1500 and greater than 225,000, which is equal to x being the probability of x being greater than 2500 minus the probability of x being greater than 1500 equals those probabilities, so 0.8783 minus point. That's interesting. Huh. These things, these answer sheets aren't proofread very well.
well, I think, well, I can't really say for, I can't really say for sure, but how I was taught in like elementary or high school, whatever, was to, if I was to use the answer sheet, like the answers in the back of the book, I had to show my math and how I got that answer.
Yeah, that makes sense. But what I'm saying is, it says we subtract
The probability.
the probability that x is less or is greater than 1500, but it doesn't say, it doesn't finish that sentence. We subtract from what? It shows you, but it doesn't finish. It's not a big deal. Next one.
Yeah.
What is the third quartile of speeds of hydrogen at room temperature?
Hmm. Let's see. So if everything, okay. So we want to import the 0.5698. 0.5698. Okay. So it would be 0.7157. What the? That's not it. I think I did a real block. I was on a roll until now.
What is the third quartile on speeds? So quartiles are determined by don't you need the median rather than the mean?
Well, I'm just trying to see how they even got that answer in the first place. And if it's using, so if the last solution, if I imported the last solution, 0.5698, then I didn't get the same one that they're getting.
The third quartile is 75%. It's just the value.
Oh, wait. It's that 10% thing again. So just import the 0.75 up top.
Mm-hmm.
There you go. 674. I got it. So all I had to do was put the 0.75 back in the top area. I just totally forgot about that whole deal of how that worked.
Okay.
Yeah. So we're good now. We're good.
Okay. All right. Are you ready to take the quiz?
Well, don't we have there's like one more thing. Plot A, plot B. The plotting.
Oh yeah, you're right.
All right. So this will be easy though. And solve is applying. Okay. Let's see. So the first one would be left skewed. Plot B would be right skewed. Plot C and D would be a line like that. I don't remember what that's called though.
Wait, which one?
Plot C and plot D. The line should go like that, but I can't remember what that's called exactly. If it's like left skewed or right. Oh, left skewed, right skewed. Oh, they're not even talking about skews, are they?
No, they're talking about if they're normal or not.
Oh. So plot A, B are not normal. Then plot C and plot D are normal. And then let's see. Plot E and plot F. Plot E is not normal. Plot F is normal.
The downward curve suggests that the data are skewed to the right.
Okay. Now I'm ready.
So, do you have like a childhood trauma?
Are you still calling me?
Well, actually, I don't. Sociology does a lot.
After this, I can't wait to go to bed.
Yeah, I'm really tired too.
Alright, so you ready to start?
Sure, yeah.
Alright. I completed the individual preparation. Yes. I actively participated in the week's group meeting. Yes. The total area under a density curve must equal the median.
False.
Is that a true false question?
Are you talking about 3?
Yeah.
The total area under the density curve must equal 1.
Okay. Thank you. Under certain circumstances, a density curve can drop below the x-axis.
False.
The density curve is symmetric. I want to say false, but what do you think?
I thought it was true, but I don't know.
Well, I don't know either.
Okay, well, I'm guessing true. So.
I'll guess false.
Okay.
That way, at least one of us will get it, right?
Okay, so...
Is that not a good idea?
I don't know. I don't
think that's a good idea, so I might have to change my answer.
Which of the following elements of the figure represents the z-score in this image?
The z-score is C. Like, I'm positive on that one. Like, 100% positive.
Yeah.
Which
Which
of
of
the
the following elements of the figure represents the probability that the random variable z will be greater than 1,000 or 1.0 or just 1. Wait, let me read that again. Which of the following elements of the figure represents the probability that the random variable z will be greater than 1?
B? I say B because,
Yeah,
like,
right.
yeah. Next one. According to the 68, 95, 97.
Wait, will be greater than 1?
Yeah, because I'm looking at the scale on the bottom. It has the -4, -3, -2, -1, then 0, then 1, 2, 3, 4. Then B is just that whole section that's above 1.
Well, I was thinking a probability of like 100%, but it meant actually 1 on the scale. I got it. I
Alright.
understand.
According to the 68, 95, 99.7 rule, what proportion of the data from a bell-shaped distribution will be within 1 standard deviation of the mean?
66 or 68.
Suppose random variable z has a standard normal distribution. Use the normal applet to answer this question. What proportion of the values from this random variable will you be between -1 and 1? Give your answer as a decimal accurate to 3 decimal places, e.g. if the answer was 3.389184, you would enter 3.89.389.
I'm going to bed now.
Oh, almost done. What proportion of the values from this random variable will be between -1 and 1?
68.3.
0.3?
68.3 because it has 0.6827, but it says round up. At least, what did you get?
The variable will be between 1 and -1. Isn't that the 68? Isn't it just 68?
Yeah, we could enter that. I was just like being more specific because on the z-score, I just entered 1 on the normal probability applet, and that's the answer I got was 0.683.
I thought that the okay, but if the standard deviation of 1 is exactly this area A, what the heck is this A? What is A pointing at? A is pointing at 2 different things. I'm confused.
A is pointing at.
At all of this whole chunk.
It's pointing at the two sections.
The red bars, right? See the red bars?
Yeah, it's not pointing at the red bars. It's pointing.
I know, but I am.
Oh.
So that area is 0 is the mean or the median, right?
Yeah.
And then the standard deviation of 1 on either side of 1 and -1. So that chunk in between -1 and 1, isn't that according to the rule? Isn't that exactly 68%?
I guess it would be, but with the normal probability applet, it says a different number. That's why I just entered a different number.
Okay.
That's my reasoning behind it.
Okay. I trust you.
Okay. Hopefully I'm not wrong, because I hate my credibility to go down a bit.
What proportion of the values of this random variable will be between -2 and 2?
95.45. But But what do we round up or round down? I can't remember.
If it's 5, you round up. Or 5 and up, you round up. 4 and down, you round down.
So 0.99. So 0.955. Give your answer as a decimal accurate to 3 decimal places.
Yeah.
1, 2, 3. Okay.
Suppose
So
random
now-
variable z has a standard normal distribution. Use the normal applet to answer this question. What proportion of the values from this random variable will be between 93? Okay.
0.997.
97. Yeah.
Look carefully at your answers to the last 3 questions. What do you observe? The values match the 68, 95, 97 rule? Yes. I'm just going to say yes. I don't need to read another one. The amount of protein that an individual must consume is different for every person. There are solid theoretical ideas that suggest that the protein requirement will be normally distributed in the population of the United States. The protein required is given in terms of the number of grams of good quality protein that must be consumed each day per kilogram body of weight. The population mean protein requirement for adults is 0.66 GP times kg negative 1 times d minus 1 negative 1 minus 1. And the population standard deviation is 0.07 GP times kg negative 1 negative 1. Use this information to answers 14 through 17. So, what proportion of the population have a protein requirement that is less than 60 GP times kg negative 1 times d negative 1? Give your answer as a decimal accurate to the 3 decimal places. You got this?
No.
Yeah.
Say 5.
It's 5.
I'm just giving up on them. What proportion of the population have a protein requirement that is less than 0.6 gold pieces? It was a joke.
Oh.
Because, you know, GP in most video games is gold pieces. Yeah. I don't know, man.
I think that's going to be used in the Excel program. Do you have it loaded?
Yeah, I can open it. What do you want me to do?
So just that equation that it gives is G, well, in parentheses, GP times kg negative 1 times d negative 1. Like, the negative ones are like in a square format.
Yeah, I got that. But I need numbers to put in.
Oh.
So it'd be 0.60 times
Less than 0.60.
what's kg?
Kilograms?
Yeah, but what's the value?
Oh.
What's the value of kg in this case?
Okay. Population mean protein. Oh, so the population mean protein requirement for adults is 66.66. So it's going to that fraction again. Okay. Each day per kilogram body weight. The population mean protein for adults and population standard deviation is 0.07 grams of protein. Use this information. So you have 0.66 on top with 0.07 on the bottom.
So this population mean requirement for adults 0.66. So I'm ignoring all this stuff. This kg to the negative, and so it's just 0.66, and the population standard is 0.07. So what proportion is less than? So just ignore all of that all the letters and stuff.
Okay.
So just the mean is 0.66. You know how to do this. The mean is
Yeah.
0.66. The standard deviation is 0.07.
0.07, yeah.
0.07. And so what proportion of the population have a protein requirement that is 0.60?
Okay, so 0.60 minus 0.66. What do you get?
0.60 minus 0.66?
Yeah.
I can't do the one with the word.
Uh,
I can't do that one that I showed you.
get 0.06 or 0.06.
Then we divide that by 0.07.
Okay.
So we get what did you get?
How was the beaver down with that word?
You get 0.857143. So it would
43?
be, yeah, 0.8. It would be 0.857.
Okay. There we go.
Okay.
Now, I got that in my normal probability applet. What
Okay.
proportion? What
So
proportion
then
of
you just take that 8.875 and you subtract it from 1. 1 minus.
You really good. I feel like
Listen, it's the blue.
let's see. It's
And
less
I get
Blue,
0.143.
How'd you get 0.143?
Subtracted 0.875 from 1.
So 0.1483?
No. So 1 minus 0.875 equals 0.143.
Oh.
Rounded.
Okay. And then what proportion of the population, 60, okay, is more than 60 grams?
What is there a way to pull a file?
Oh, wait, I did that wrong.
So is it 0.1956?
Sorry, it was, I switched the numbers. Oh, no, wait, the first one was 0.857.
Yeah.
0.875.
0.857.
And the next one is 0.143. Is that what you already had?
So
Okay.
13 was what?
13 is what you said. It's 0.857. Right? Isn't that
Okay.
what you said?
Oh, it was just I just got that answer for the z-score and just put it into the z-score.
Okay, what did you say it was?
Well, I said it was 1.1957. I don't know if that's correct.
That's impossible. 13 you said was point. Well, what?
Okay, so I incorporated the 0.857 into the z-score on the normal probability applet.
Yeah.
And then I just did the less than proportion on the z-score, and I just highlighted the section, and the section came up with, of the area, came up with 0.196, rounded up.
0.19. So the answer to 13 was 0.196?
At least to my knowledge, I could be wrong.
What is the proportion of the population? What proportion of the population have a requirement? A protein requirement that is less than 0.6.
I just did the same answer because I highlighted the other side as well.
And you came up with what again?
0.196.
Okay, so then the other answer is wrong. The one I gave you, 0.143, that's wrong.
Okay.
The answer would be. Sorry, 1 second. The answer would be, I think, unless I'm wrong. 6, 4. It's 0.804.
Wait, which one is that? Is that 15?
14.
So that's what was the answer again?
If the answer to 13, right? If the answer to 13, ow. If the answer to 13 is 0.196, then the answer to 14 is 0.804.
Okay.
I think.
Okay, so that's what the answer I got for the next one, though. What proportion of the population have a protein requirement that is less than 70 grams? And with that, I just went to the normal probability applet and just went to the red line, and I just highlighted the two sections to the left. And I came up with 0.804.
Okay. But doesn't the complement rule demand that if so what is the proportion of the population that have a requirement? So what proportion of the population is less than 0.6? And then the next question says is more than 0.6. So wouldn't it just be that minus 1? Or am I not understanding?
I think what it's doing is just asking for individuals for the 13 and 14, like the individual sections. At least that's what I think it's doing.
What do you have for 14?
14, I had 0.196.
I thought you said that was your answer for 13.
Yeah, because like on 13 and 14, okay. So on the normal probability applet, I just had the 0.857 as the z-score, and then I highlighted each section individually. But when I highlighted one section, it came up with the same number as the other section that I highlighted.
Okay.
Make sense?
Yep.
All right.
Then your answer for 15 is 0.804.
Yep. Because it's asking for less, like, what protein is less than 70 grams. And then right there, I just went to the red line, and I just did the sections to the left.
Okay. Cool.
So, find the probability that a randomly selected person will have a protein requirement that is between 60 and 70. Remember that to find the area between two values shaded to the left of each z-score, you calculate and then subtract the smaller areas from the larger area. Make sure your answer is positive. There is a probability that the randomly selected observation will lie between the two values. Give your answer as a decimal accurate to the 3 decimal places. Okay, so z-score time. Okay, so 0.60. Okay, so 0.60, 0.70. Okay, let's try this.
It's the same as what we just did. So it's subtracting the probability of one from the other. Remember that?
No.
We just looked at it. It was the last. Remember the answer, the question 7. 7E.
Oh, and the
From the homework.
7E. Just a sec, my windows are all over the place.
Sure.
All right, so 70 was probably okay. All right,
All it is subtracting the probability of the one from the second one. So you take the probability of what was it?
I remember it. I also
Yeah. So you take the probability that it's I think this is it. You take the probability that it's 0.7 gram or 0.7 whatever, and you subtract or sorry, you take and then you subtract the probability that it's 0.6 from that. Does that make sense?
Yeah, so it's like giving you two different answers.
Kind of. Find the probability of both. So if you find the probability of 0.7.
Okay, so
And then find the probability of 0.6. I'm going to call 0.7A and 0.6B.
Or like from the northwest, must be like a little come as you are.
shoot, can't remember.
You know how to find the probability. You know how to find the probability of 0.7, right?
Well, just with the normal probability applet, that's it.
Okay.
And
So find the probability of 0.7.
0.242.
Okay. 0.242.
And then with 6, it's 0.274.
And the other one was what?
0.274.
Okay. So we take. Let's see. I think. 0.6. So the probability for 0.7 was 0.242.
Yep.
And the probability for the other one was 0.274.
Yep.
0.6.
Yeah, you're right. 0.274.
So you subtract them from each other. Subtract one from the other, rather, and you get 0.032. And that's the best I can do.
Okay. You ready to submit?
I wasn't more helpful this time.
Yeah, don't worry about it. I wasn't helpful last time, so it was just transition. We'll get it.
And C+.
I got also C+.
What was your percentage?
77.
Mine too. Oh, so I got that question wrong, but then I didn't complete the first part.
Okay, I was wrong on 14 and 15, so that was my fault. Oops. Sorry. My credibility just went down. And you were right on number 5. By the way. Hello? Oh no! Lost contact with you. Hello? I can't hear you. Hello.